Assalamualaikum and hi everyone. My name is Dayana Nufarhana binti Muhammad Zalani, S46915, and my supervisor is Dr. Sandra Catherine Zainatan. So today I would like to present my final year project entitled Molecular Detection of White Spot Syndrome Virus WSSV in White Leg Shrimp Penuas vanami from Shrimp Farm Setiu, Terengganu, Malaysia. The last few years, global farm shrimp production have grown rapidly. The production has expanded from 3 to 5% over 2017. Among these species, Penuas vanami is most popular because they can withstand in wide range salinity and can grow fast than other shrimp. While for shrimp production in Malaysia, total production in 2012 was about 6.4 million tons. White spot syndrome virus WSSV infects a wide range of aquatic crustaceans of all life stages in marine, brackish and freshwater including pennies, crabs and crayfish. One of shrimp farms in Setiu has recently hit by an outbreak of WSSV infection. Thus, this study was conducted to detect the presence or absence of WSSV in Penuas vanami from shrimp farm Setiu, Terengganu, Malaysia. For the significant study, it is to determine the presence or absence of WSSV in Penuas vanami and to investigate potential pathogens and develop strategies and control to prevent the spread of disease. And the objective of this study is to detect the presence or absence of white spot syndrome virus WSSV in Penuas vanami from shrimp farm Setiu, Terengganu. Penuas vanami is also known as the Pacific white leg shrimp or white leg shrimp that belongs to the phylum Arthropoda in the order Decapoda, and it is from family Pennidae. The last few years, the shrimp production suddenly been dramatic decline. The main viral pathogen found in pennate shrimp is white spot syndrome virus. White spot syndrome virus is one of the viruses that easily widespread and causing high mortality among shrimp. This virus kept being most contagious pathogens because it is highly virulent and can be reached 100% of mortality just within 3 to 7 days of infection. So this is the summary of WSSV cases that had been submitted. For methodology, 50 samples of Penuas vanami was taken from a shrimp farm Setiu, Terengganu. Next, gills and pleopods undergo sample processing and the DNA extraction is done by using GF-1 variant nucleic acid extraction kit. Next step is PCR analysis according to the method by Low et al. 1996 and as described in OIE 2013. The amplified PCR product from the reaction was analyzed by electrophoresis for 45 minutes at 70 volt on 2% agarose gel in TAE buffer and stained with CyberSafe. For the result, no clinical signs were observed on all of the sample. The average weight was 16.8 gram and the average length was 12.4 cm. The primary PCR analysis demonstrated negative result for the presence of WSSV and no bands appeared. The next PCR analysis demonstrated negative result for the presence of WSSV and no bands appeared too. A total of 50 samples of Penuas vanami have been collected from a shrimp farm at Setiu, Terengganu to examine the presence of WSSV by PCR analysis in this experiment. No clinical signs were observed on all of the sample and can be considered as a healthy shrimp. The common clinical signs of WSSV infected in shrimp are white spots, changes in behavior, a dramatic drop in food consumption, and shrimp always locating on the surface of the water and close to the edge of the aquaculture pond, but those clinical signs not appear in the sample of the study. Previous studies showed that 30 grades of shrimp sample were obtained from Bong El Arab Carbonate of Alexandria with no symptoms and clinical signs, and the result shown negatively instead of the one with symptoms and white spot on their carapace. 11 out of 120 shrimp were WSSV PCR positive, and common clinical signs of WSSV in the gastric epithelium and gill were clearly seen on the sample. Next, the PCR results showed that infected samples of shrimp were positive for WSSV, while in healthy shrimp with no infection and clinical signs were absent. Recent study by Arts et al. 2007 indicate that the gills were the main multiplication site of WSSV, and the general technique to distinguish between the healthy and unhealthy shrimp is by the color of the shrimp. In conclusion, 50 samples of Penuas vanami collected from shrimp farm Setiu, Terengganu were detected negative for the presence of WSSV using conventional polymerase chain reaction. The primers used in this experiment for PCR amplification are as recommended by OIE 2015 and designed by Low et al. 1996. A few recommendations can be made to achieve a more reliable outcome, like increasing the number of the sample. For further study, experimental challenge should be conducted to confirm the status of WSSV. That's all from me. Thank you.